Imagine this. You've just sat down on your couch to watch a video. Just as you get comfortable, a f***ing ad shows up and you have to get up to skip it. We can all agree that this is the single worst thing happening to millions of people around the world today. Fortunately, for the good of humanity, I've decided to fix this problem once and for all. The plan is simple. Use sound to control the cursor on the screen, allowing me to sit back and relax and let my voice act as a remote controller.
Force Brother!
Alright, maybe that intro was a tiny bit dramatic and a bit exaggerated, I can admit that, but still, wouldn't it be cool to control your computer with your voice? And I don't mean like a voice command kind of way, computer do this, computer do that. No, I mean controlling the cursor directly. Now, how exactly are we gonna do this? Well, if you thought we were doing some AI neural network type of shit, then I'm sorry. Because the whole logic is basically gonna consist of a couple of if statements. The idea is to move the cursor to the left if the pitch of my voice is below a certain threshold, and to the right if it's above. If you instead want to move the cursor up and down, just whistle or make any sound above 1000 Hz. This will cause a low frequency to move the cursor down and a high frequency to move the cursor up. Lastly, we need a mechanism for clicking with the cursor. After some experimenting, I found out that this noise consistently produces sound around 800 Hz, which is outside both my speaking range and my whistle range, making it perfect for clicking. Now, getting the input from the microphone was actually very easy because we are using Python, and for you who don't know, Python basically means we don't need to do any of the difficult programming ourselves, as we can just find a package that's already done it. The package we're gonna use is called Sound Device, and with some cheeky theft of code, we can now visualize the sound waves. Ba ba ba, skibbity ba ba ba. The second step is actually finding the dominating frequency or the pitch of my voice from the microphone. This means using the mathematical magic trick of the Fourier transform. In a broad sense, this means taking a signal and splitting it up into its frequency components. And that way we can find the most prominent frequency of any sound input and identify the pitch. So I'm not gonna explain how the Fourier transform works, partly because I don't understand it, but more importantly, 3Blue1Brown has already done it way better than I ever would. So when reading about the fast Fourier transform, which by the way revolutionized signal theory after its invention in the 60s, I found out that they actually found the whole algorithm in some unpublished work from the 1800s by the famous mathematician called Frederick Gauss. I find it crazy that Gauss had come up with this famous algorithm 100 years earlier, and the reason he didn't publish it is because he didn't actually think it was that important, which I think just proves how fucking stupid Gauss really actually was. Armed with a 19th century algorithm, we're now ready to pick up the pitch of any sound, and to illustrate this, I've set up a little test program. The plot in the top is the Fourier transform of the input signal, and the number you see is the most prominent frequency picked up by the microphone. The bottom is just plotting the strongest frequency over time. To make sure it's accurate, let's play a middle A on this harmonica. As expected, the dominating frequency is 440 Hz. However, there's a lot of overtones being registered. Without these overtones, the sound would just be a pure sine wave. These overtones are present in my voice as well, which can potentially cause problems when we're trying to pick up the pitch. For example, if I make the same sound with an open and then a closed mouth. As you just saw, a completely different pitch is registered as the main frequency when my mouth is open compared to when my mouth is closed. To get around this problem, instead of taking the most prominent frequency component, we can look at the 4 strongest and pick the lowest one of them. With the movement implemented, we now have the finished program. So let's try it out. The cursor speed is scaled by how much higher or lower the pitch is than the 200 Hz threshold. The clicking and axis switching also works as intended. We're finally ready to use the program for its original purpose.
After some changes to the code, for example scaling the speed with the volume as well as the pitch, I think we are ready to use this voice control to play some games. I initially wanted to use it in Counter-Strike, but I quickly realized that the chances of me actually getting a kill are pretty much zero. So instead I found this game called Deadshot, and it's filled with little kids having their first go at a first-person shooter, which increases our chances of getting a kill. After getting used to playing with my voice, I actually managed to score some kills. If you wanna try this yourself, just go to the description and I will leave a link to the code. And that is it. I hope you enjoyed the video. Go to the description, try out the program yourself, and see you next time.